Assalamualaikum warahmatullahi wabarakatuh. My name is Noaliza Binti Mazam and my lab partner Azima Binti Zainal Abidin. We will explain about lab 5 filter design and application. Okay, first we go to the procedure for task 1. Okay, for the task 1 we have to identify the signal and noise component. Okay, and then we have to do this figure on the Simulink. We go to the Simulink. Okay, and then this is the figure that we have done, and we have input the component, which is the multimedia file. The multimedia file we get from the mystery sing1, and then we input the component for time scope, spectral analyzer component, and then audio device writer, and then we have to run the Simulink. Okay.
The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate symmetric.
Okay, as we can hear the sound of the voice of men speaking, and this is the result on the time scope, and then this is the result for the spectrum analyzer. Okay, and then we have to on the spectrum analyzer, we have to pin at the frequency which is 7.35 kHz. Okay, and then for the task 2 we have to input the coding. Task 2 is the function of task 2 is to identify the filter, and then we have to input the coding for this low pass filter. Okay, and then this is the coding for the low pass filter. We input on the script, and then we run the coding. Okay, this is the result for the time scope. This is the result for the coding for the low pass. As we can see here, we use the function of the butter, and then we will get the graph like this, and then the title is magnitude response. Okay. Okay, function of low pass filter is to remove the noise on the audio. Okay, and then for the noise filter, okay, we have to input the specification on the band pass filter, which is noise filter, and then the N is the filter order, and then FO is the noise frequency, and then the 3 dB bandwidth is 200 Hz, and then the sampling frequency here is 22,050, and then we use the noise command, fdesign noise command, and then this is the coding, and then we evaluate the coding. Okay, as we can see here, this is the result for the noise filter, and then we see here on the frequency 7.3 something kilohertz, that the graph below zero, and then for part 3, okay, for part 3 is we are required to using B-quad filter block diagram. Okay, so okay, for the task 3, this is the circuit for the task 3. Okay, we use the multimedia file and the B-quad block component, and then we use 2 spectrum analyzer, and then we use the audio write device, and then from we run the Simulink, and then we get that on the spectrum analyzer first, we get this is the graph from the first spectrum analyzer, And then this is the graph from the second spectrum analyzer. And then from there we input the coding on the my low pass, and then we will get the result like this. And then for the result will be become like this because we use the butter function. And then we use the FB-Tool HD to visualize the graph. Okay, and then for the task 4, okay, for the task 4, this is the Simulink that we have done. We use the noise filter here, and then same we use the both spectrum analyzer. We change the Biquad filter to noise filter, and then we run the coding. We run the simulation on the Simulink, and then this is the result on the analyzer for the spectrum analyzer. Okay, and then this is the result for the spectrum analyzer on second analyzer. Okay, the difference between Biquad filter and noise filter, the sound of the on the noise filter, the sound of the man speaking becomes smooth compared to Biquad filter. Okay, I will pass to Azima to explain about task 5.
Okay, thank you to Aliza. Okay, for task 5, we are using this Simulink digital filter, and we insert the mystery signal 1, and we use a filter designer, and we use to analyze the spectrum, and this is an audio device. And then we run. So we double click at the filter designer. We need to setting it first, low pass, and run the Simulink, and this is a result we get on task 5. First analyzer first and analyzer second. So as we can see, the different signal we get. Okay, next filter, we use a filter designer for task 5, and we setting also the filter designer. We double click and setting at this. Use specification mask to analyze plot design and realize the model, and then double click on the generator filter block to see filter structure and run the model. Okay, after we run the model, we get the result like this for analyzer 1 and second analyzer. Okay, for task 6, okay, for task 6, we use mystery signal 2, and we use to analyze the spectrum, and we use filter design, and then we double click at the filter design to setting low pass. As you can see here, the setting, and then we realize the model, and automatic filter block will be at the Simulink, and we run the Simulink first. Okay, as you can see here, the result for task 6, analyzer 1 and analyzer 2, we can see the difference from two type of spectrum analyzer. Result that slightly look like low pass filter. Okay, for discussion, in task 1, we were required to simulate the component given on the Simulink to identify the signal and noise components. From the result, we were able to visualize the signal in the time scope and spectrum analyzer. On the spectrum analyzer, we were required to characterize the signal component and noise component at the frequency of 7.35 kHz. In task 2, we were required to identify the filter, either low pass filter or notch filter, to remove the noisy of the same circuit. We are using FV2 to visualize the graph for low pass filter and notch. From the result, we know that the low pass filter is required to remove the noisy, which allow the low frequency component to pass through while attenuating high frequency component, while notch filter remove only a narrow band of frequency. In task 3, we were required to using backward filter block. As the result, the audio of the main speech is become muffled compared to task 4, where we required to use peak notch filter block, which the sound is smooth. In task 5, we were required to use digital filter on the circuit and input the setting for low pass. The result is shown as given, and the input setting for notch filter on digital filter, and show the graph on spectrum analyzer. As we can see, the graph for low pass filter and notch filter on the spectrum analyzer is different. In task 6, we were required to use filter realization wizard from the graph obtained on spectrum analyzer and analyzer 1. We can see the graph is different. Okay, that's all from us. Thank you.